So at Anthropic, we make trustworthy AI. We do industry-leading fundamental research in both capabilities, making models better, and safety. And we build Claude, which is one of the world's frontier LLM families. We make it available, among others, through Amazon Bedrock. I am on the compute team, so part of my responsibility is planning and structuring the computational infrastructure that powers our training, our inference, our research, everything we do. And I'm always looking for the most cost-effective, most scalable compute platforms in the world for us to use in all of our work. Earlier this week, my colleague Tom was on stage at Peter DeSantis' keynote, and he announced that we're betting big on Trainium, especially Trainium 2. We're using Trainium 2 for fast, low-latency Claude inference, and we're working with AWS on a truly massive new Trainium 2 training cluster called Project Rainier. I wanted to explain in a little bit more detail basically why we made that choice, why we're betting on Trainium. So first and foremost, we're looking for the best price performance at the largest scale. Those are the core goals that we care the most about. And Trainium 2 gives us great performance per dollar, especially on memory bandwidth bound or memory bandwidth sensitive workloads. And then on the scale side, we can rely on AWS for their world-class data center infrastructure experience. Really, they've built this for larger scale than anyone, and their expertise in large-scale capacity delivery. This kind of cluster is not routine for anyone, but it's the closest to routine for Amazon. And then we've learned a lot about the Trainium chip architecture over the last year or so, and really appreciate the flexibility, the programmability of all of the hardware engines in the neuron core. And then we can write low-level kernels that basically pipeline workloads across the different engines to absolutely maximize tensor utilization, squeeze out the most performance we possibly can. And then we can use the neuron profiler that Ron demoed to see exactly what instructions execute when and where on the chip. Almost no other accelerator can do that. And that really gives us the tools that we need to optimize all of our workloads. Oops. Oh, no. So then the last thing is that we're incredibly excited about the ultra server architecture and scaling out to support more kinds of parallelism on larger and larger models, both for LLM inference and LLM training. I think that the combination of ultra servers with neuron link and very large scale, high bandwidth, low latency EFA, the 10P, 10U, this combines for just really exceptional, smooth scalability up to very, very large training and inference workloads. And then last but not least, we're just incredibly appreciative of the phenomenal collaboration that we have with Ron and the Annapurna team, with Joe and the EC2 team, just everyone that we've worked with at AWS on everything Trainium. So Ron talked about clusters of hundreds of thousands of Trainium 2 chips, and Tom talked about Project Rainier. What is it going to take for us to train at anything close to this scale? That's something we've thought a lot about, something we're spending a lot of time on. We need innovation at every level of the stack. And really, our team is already working hard on different aspects of what it will take to scale to Project Rainier. So ultra servers and EFA enable different new approaches to parallelism, and we want to really optimize what's the best way to take advantage of all of these different kinds of parallelism, the different kinds of network in the cluster. And then the Trainium architecture, the neuron core engines, and tools like Nikki and the neuron profiler, they enable us to squeeze almost every last flop out of the chip and system. And we're going to need to do this because there's new bottlenecks at every scale, and we need to sort of constantly be profiling and optimizing and trying to figure out what the next, how to unblock the next bottleneck, unblock the next scale up. And then on the other side, we need a corresponding amount of work on basically reliability and testing. Large-scale, innovative reliability and testing infrastructure, because there's inevitably going to be hardware and system failures, and when you multiply them by the size of this cluster, they'll happen very often, and then we need to figure out how to adapt to them. And it's a new chip at unprecedented scale, so I think we're quite optimistic, but there's going to be problems we couldn't even imagine. But you know what? This is our favorite kind of challenge at Anthropic. We really like working at unprecedented scale. We have a phenomenal team dedicated to every aspect of this. And it's just this is what our company is built for. And then today, you can already use the first result of our Trainium 2 work, which is a latency-optimized implementation of Claude 3.5 Haiku on Bedrock. So it's up to 60% faster for both inputs and outputs than the standard Claude 3.5 Haiku on Bedrock. And that means up to, depending on the prompt distribution, up to 125 output tokens per second. We're really excited to bring Trainium 2 inference and lower latency to more models soon as well. Just for this demo, we hooked up Claude.ai to the latency-optimized Trainium 2 Haiku 3.5. So we're going to show a little video of, I've created a Claude project that includes all of the Nikki documentation. That means the programming guide, example kernels, architecture guides, everything that AWS and Anthropic have written about Nikki and how to program in Nikki. So we're going to try to teach Claude a new programming language, essentially, that it's never seen before because Nikki is new. And we'll see how it goes. So let me get started. Yeah. So we loaded all of this into its context window. And we're going to ask Claude to write a kernel for softmax, and then explain each line in the kernel. So right now, it's going through processing and caching about 100,000 tokens of context on Nikki. So all of these example kernels, et cetera. And that's going to take a few more seconds. OK, now it's done. It is generating code much faster than Sonnet 3.5 and other models. And you can barely keep up with how fast it's generating code. But maybe softmax is too easy. So now what I'm doing is I'm pasting a description of an activation function that Anthropic came up with and talked about in an old blog post, and asking it to write a kernel for that. So it's using a programming language it's never seen before to write a kernel that it's just learning about today. And I haven't gone through it super closely, but I think it's doing a pretty good job. And the output is sort of coming out faster than we can keep up with.